Hello everyone, welcome back to my channel Gemsofknowledge. So I'm here with another new video on SSLC most important laws of this year. Okay, so here are the 6 laws as you can see. Okay, continuation, there are 6 laws which are most important for the board exams. So before starting my video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new videos. So the first law here is laws of reflection from light chapter. Okay, so in the laws of reflection there are two laws. First one is the incident ray, the reflected ray and the normal all lie on the same plane at the point of incidence. So this is the first law. So this is the diagram dependent on this law. Okay, whereas you can see an incident ray, reflected ray and the normal, three types of rays you can see. This is incident ray, and this point, as you can see, this is called as point of incidence. Okay, so the incident ray, the normal ray and the reflected ray all lie on the same plane. They lie on this same plane at the point of incidence. This is the first law. Okay, second law is the angle of incidence is equal to angle of reflection. So this incident ray at whatever angle it is making here, okay, this is equivalent to this angle, means equivalent in the sense both the angles are equal. If this incident ray is making a 40-degree angle here, then with the same 40-degree angle it has to move away from this point of incidence. You can see the arrow marks here. Incident ray is the coming ray which is hitting at this point and going back in this direction. It is called as reflected ray. After reflection it is going back. Okay, so angle whatever is formed, this is I, that is angle of incidence, and this is R, angle of reflection. Okay, so I hope this law is cleared. Similarly, we'll go to another law which is law of refraction from the same light chapter. Here the first law is obviously the same, okay, the incident ray, but in case of reflected ray it is refracted ray. Okay, this is refraction, so it is refracted ray, and the normal at the point of incidence all lie on the same plane. So the same diagram won't specify here. This reflected ray will be refracted ray. In case of refracted ray, it won't come in the upward direction, instead it will bend in this direction. Okay, so the figure will be somewhat like this. Okay, this is the normal which I'm drawing. Okay, this is the incident ray which is coming from here, and this will be the refracted ray. After reaching this point, this is the refracted ray. Just instead of coming from here, it will be just bending. Okay, that is refracted ray. They all lie on the same plane. This is the same plane. Okay, these all three lines lie on the same plane. Okay, second one is the ratio of sine of angle of incidence. So the sine of angle of incidence, okay, angle of incidence, sine of angle of incidence to the sine of angle of refraction. So whatever refraction angle it is making, it is constant. So that is sin I by sin r is equals to constant for any given of light. Okay, for any given of light which is of any color or any pair of media. Any pair of media means either if it is passing in the gas media in the sense in the case of gases, or either it is passing in water like liquid. Okay, whatever media it is. This is also known as Snell's law of refraction. This law is also called as Snell's law of refraction. Mathematical form is sin I by sin r, which is equal to n, where n is a constant. Okay, next, moving to the third law, that is Ohm's law. The potential difference V across the ends of a given metallic wire in an electric circuit. So you need to know the potential difference here. okay, the current here and the resistance here. I'll let you know the potential difference V. So the potential difference is denoted by the letter V across the ends of a metallic wire. Okay, whatever potential difference that particular wire is having in an electric circuit, is directly proportional to the current. So this is the figure, this is the symbol of directly proportional. V is directly proportional to I, current flowing through it, but the temperature remains the same. The condition is the temperature won't be changing, only the potential difference is directly proportional to the current in the circuit. Means if the potential difference increases, current will also increase. If it decreases, current will also decrease. Okay, so to remove this proportionality sign, one constant we are needed, that is R, resistance. If we add this constant, then this proportionality sign will change to equal to. So the main formula here is V is equals to IR, means I into R. So where V is potential difference, I is current, and R is nothing but resistance. So this is the graph which is related to your Ohm's law. This is current. Okay, on x-axis always taken as current, on y-axis always we take it as potential difference, and this is the graph always we get. Whatever the points we plot, we will always get it in a straight line. Okay, the Ohm's law graph will always be in a straight line. Okay, so moving to the next one. Okay, so the next one is Joule's law of heating. So here it says that heat produced in a resistor is directly proportional to the square of current for a given resistance, directly proportional to the resistance of the given current, and also directly proportional to the time for which the current flows into the resistor. So basically you have to remember this formula. The H is equals to I square RT. If you remember this formula, you can easily write the above 3 points. As you can see, H is for heat produced in a resistor. When the heat is produced into the resistor, then 3 things is going to be happened here. You can see I stands for current. Okay, it is directly proportional to square of current. Okay, I square, that is directly proportional to the square of current for the given resistance. Okay, whatever resistance we are giving, it will be double of the current. Okay, square of the current. Next is directly proportional to the resistance for a given current, that is R. Okay, and directly proportional to the time for which the current flows. In what duration of time the current flows, it depends on that particular time. Okay, so mathematically you can write these things. H is equals to I square RT. Next comes right hand thumb rule. Okay, so here you need to imagine you're holding a current carrying straight conductor. If this is a current carrying straight conductor, okay, you need to think that you're holding it into this way. You're holding it into this manner. Okay, like this. So current straight current carrying straight conductor, in the sense particularly a wire in your right hand, it must be in your right hand, such that your thumb points. Okay, you can see, you could have seen the thumb, this points towards the direction of flow of current. This shows how the current flows. Okay, and then my fingers wrapped around the straight conductor, this fingers, whatever it is wrapped, it shows the direction of magnetic field lines around that conductor. Okay, it shows the magnetic field lines, how the magnetic field lines are wrapped around that particular wire. This is nothing but right hand thumb rule. Next comes the last one, Fleming's left hand rule. So this is according to your left hand rule. Stretch your thumb, forefinger and middle finger of your left hand. So if this is your left hand, you need to stretch it in this manner such that they are perpendicular. You can see a 90-degree angle between this and this. Similarly this and this. Okay, and this finger. Okay, stretch your thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular to each other, such that they are 90 degree to each other. Then if the forefinger points the direction of magnetic field, we need to remember that our forefinger will point towards the direction of magnetic field, middle finger will points in the direction of current, and the thumb will points in the direction of motion or force. Okay, so these are the important six laws of this year 2020-25. You can expect a 1 mark or 2 mark question regarding this. So few questions I have written below, okay, which are based on your model papers, means the previous papers. Okay, so you can see the question over here. Name any two devices that work on application of Joule's law of heating. So these are the devices which works on the Joule's law of heating. Either it is iron box, toaster, oven, kettle, bulb or fuse. So these are the devices. You can name any two devices which works on this law. Okay, next one is state the rule to determine the direction of. Okay, here two questions are given and you have to mention the rule which shows the direction of these things. Okay, so what is the first thing here? Magnetic field produced around a straight conductor. So how, when the magnetic field is produced, in which law magnetic field is produced? There are two laws, okay, dependent on magnetic chapter. Okay, which are those two laws? Right hand thumb rule and Fleming's left hand rule. So here they have told us that magnetic field produced around a straight conductor. So the straight conductor comes in which law? You just can see here. Imagine you are holding a current carrying straight conductor. So it comes under the right hand thumb rule. So the answer to your question is Maxwell's right hand thumb rule. Right hand thumb rule was given by Maxwell. So it is shown as Maxwell's right hand thumb rule. Okay. Next one. Force experienced by a current carrying conductor placed in a magnetic field which is perpendicular to it. Okay, so here they are talking about the force which is experienced by a current carrying conductor. So we are having a current carrying conductor in which the force is felt, okay, which is placed in a magnetic field and it is perpendicular. So perpendicular comes in which rule? It comes in Fleming's left hand rule. So the answer to your question is Fleming's left hand rule. So let's go to the next question. Okay, so here is a multiple choice question. The rule that helps to determine the direction of magnetic field around a current carrying straight conductor. So a straight conductor is given. Okay, so I told you earlier in the before question also, whenever the straight conductor they have mentioned, straight conductor will be having only in one law, that is which law you have to mention. Okay, so what they have asked here, the rule that helps to determine the direction of magnetic field around the straight conductor. So the fingers wrapped around the current conductor will show the magnetic field. We have learned in which law? That is right hand thumb rule. So the answer is right hand thumb rule. Okay, so moving to the next question. Imagine you are holding a straight current carrying conductor as per the right hand thumb rule. So according to the right hand thumb rule, you are holding a straight straight current carrying conductor. Okay, so if the thumb is upward direction, okay, so you may have seen the figure of right hand thumb rule which shows the finger this will be in the downward direction. The thumb is in the downward direction. Now they are telling that the thumb is in the upward direction, then the direction of field lines of magnetic field will be. Okay, so how the direction of the magnetic field lines are supposed to be? They are asking. If it is moving in a clockwise direction, if the thumb is in the downward direction, then all the fingers which are pointing your magnetic field is moving into this direction, that is clockwise direction. Now if the thumb is in the reverse manner, then obviously it will move into a anti-clockwise direction. So here they have given upward and downward. So this downward and upward is not there because the magnetic field are moving in a circular manner, so it is not moving in a downward or upward manner. Either it should be anti-clockwise or clockwise. When it will be clockwise, when the thumb is pointing into the downward direction. When it will become anti-clockwise, if the thumb is pointing towards the upward direction. So this is the answer, that is anti-clockwise. Okay. Next one, in Fleming's left hand rule, middle finger indicates the direction of what? They are asking. Magnetic field, electric current induced in a conductor, electric current or movement of the conductor. So the middle finger will shows the current which is induced into the conductor. So the answer is B1, electric current induced in a conductor. Okay. The last question, what does the thumb indicate in the right hand thumb rule? Obviously we have studied here. What does the thumb indicates? Thumb indicates the current carrying conductor. It means how the way of what is the direction of the current it will indicate. So the answer will be direction of the current. So that's all for this video. I hope you have understood with all the questions and all the laws. If you are having any doubts regarding, you can comment me down below. So I'll be back with the another video. So till then, stay tuned and stay connected. Thank you.